This algebra 1 less than 2.1, talking about the real number line. We're graphing and comparing real numbers using the number line, and we're finding absolute values and opposites of numbers. Not always the exact same thing. First thing, we got a bunch of definitions. The first one is real numbers. What are real numbers? Everything we're going to deal with in this class are considered real numbers. Mostly everything you'll deal with in your next math geometry is going to be real numbers. You won't get to something that's not considered a real number till you get to algebra 2. Uh, what real numbers are, though, or is the best way I can describe what a real number is to show you something that's not a real number. Um, the square root of 4. Some people look at that and they understand that that means what number times itself gives you the number 4. The answer is 2. So the square root of 4 is 2. What about if I asked you for the square root of negative 4? This is the easiest example about something that's not a real number. There's no real number that when I multiply it by itself gives me negative 4. Because if I multiply 2 times 2, I get 4. If I multiply negative 2 times negative 2, I get 4. I never get negative 4. So what mathematicians came up with is a way where you can still solve this when you're looking at it in an equation or in an example by multiplying it by an imaginary number. You would multiply this by the square root of 4 by I. It's called an imaginary number. And then you would solve it like this one, and it would become 2 times I, or 2I. So this is the first non-real number you're going to deal with. We will not look at this. I will not even mention this again in this class. We won't deal with it. But when you get to algebra 2, you'll say, oh, yeah, maybe that's that crazy stuff Coach King showed me that one time. Everything from this point on in this class, when we talk about numbers, will be considered real numbers. Okay. So everything is considered real numbers. A real number line is a horizontal line. That's a line that goes this way. And it has real numbers as points. Some lines are more detailed than others. Some of them will be something as simple as 0 and 31. Some of them will have a bunch of tick marks, like there'll be 10 here, and then 20 here, and then 30 here, however it goes. But that's a real number line. It has both positive and negative numbers on it, and it's going from left to right. It's horizontal. Negative numbers are all of the numbers that are on the left side of 0. So as you're looking at the number line itself, if 0's here, all of your negative numbers are everything on this side. Remember, negative numbers, as you go to the left, they get smaller, but the number looks larger, like it's -1, then -2, then -3, that way infinitely. That's what the arrow means. It goes on forever. Positive numbers are everything on the other side. These are the numbers that you count by, the numbers you've been dealing with since you've been little. 0's there, all the numbers over here, like 1, 2. Nobody usually has any issues with positive numbers. It's just going from positive to negative sometimes that messes with people. Integers are the numbers that you typically count by. Okay? Integers don't have any partial numbers at all. There is no 1 point anything or 1/2 of anything. Integers, when you solve them or when you simplify them, you consider them whole numbers. That's what most of us think, but there's actually something called whole numbers. That's why we call these integers. Now, this is an integer, 4/2, even though it looks like a fraction, because we know we can simplify 4/2. 4 divided by 2 becomes the number 2, which is an integer. So don't, right when you look at something, don't assume it's not an integer just if you see a fraction, because it might be a number that we count by. A graph is the actual point that shows up. So this is the number line, this. This is the number line, looks like this. The graph is this. That's the graph, the point itself, not the whole thing. A lot of times people confuse the number line with the graph, and most of the time it doesn't make a difference. That's why most people make that mistake. But the actual point is the graph. We're going to graph lines in here. That's one of our goals this year. It's to graph lines, and some of y'all already know how to do that to an extent. we're going to start graphing lines. The line itself will be what's considered the graph. Plotting is actually drawing the point. So drawing the point, this is the number line. If I plot the number 2, or if I plot the graph 2, that's doing this. I just plotted it. It's the actual doing of it. Okay, most people don't have any issue with opposites. Opposites are very simple. Where mistakes come in, though, is when we start comparing opposites and absolute value, which we're going to do in a second. The easiest way to not make a mistake, if I ask you for the opposite of the number 3, for example, we know 3 is there. So 3, this distance here from 0 to 3 is 3. You do the same thing. You go the same distance here, and the opposite would be -3. Again, same thing. If I ask you what's the opposite of -3, you just find the same distance from 0. This is where it gets confusing to some people, because some people think they see the absolute value. When you read, anytime you have 2 bars like this around something like the absolute value of -2, just read it as the absolute value. Don't say those bars thingies. Just call it the absolute value. That way you don't make a mistake. Absolute value is a distance. That's the easiest way to understand that, a distance. There is no such thing as a negative distance. If I take a tape measure and I stretch it out to you from where I'm standing, the way you're sitting right now, and it says 10 feet, and then I'll let the tape measure suck all the way back in, and I throw you the tape measure, and you stretch it all the way back out to me, it's not going to say -10 feet, right? It's going to say 10 feet. Distances can never be 0. So since we're talking about the absolute value, and the absolute value is a distance, it's always going to be a positive number. It's not the opposite like this one. The opposite will be negative sometime. The absolute value will always be a positive value. Velocity is the speed and the direction. This is typically done when something's going up or down. As something's going up, if you were to draw a graph right here that had the time on the bottom and then the distance on the y-axis, as time is increasing, distance is increasing. The velocity is going up right here. If this were to go down like this, then it would get a negative value. So velocity is both speed and direction, both of them together. When it's going up, it's positive. When it's going down, it'll be negative. And then a counterexample is anything that makes something false. When you prove a statement to be false, you don't have to prove it to be false again. Once it's false, it's false. So anything that makes something not true, and we're going to look at some counterexamples in a minute. Okay, here's example number 1, comparing real numbers. And I know a lot of these are already done. For some reason, these worksheets, when I put them out, the graphs a lot of times will be colored in. It's okay. You can still do the rest of it. It says graph -3 and -7 on a number line. Then write 2 inequalities that compare the 2 numbers. So -7 is what? -3. And this was just like our bell work. -3 is what? -7. Okay, it was talking about which mouth is eating the bigger number. Remember, 7 looks like a bigger number, but if it's negative, it's actually smaller. So the bigger number in this case would be -3, so it should look like this. Big mouth should be eating the -3. So on the graph, -7 is to the left of -3, so it's less than it. On the graph, -3 is to the right of it, so it's greater than it. And again, those are the 2 inequalities I just made. Okay, on the back, everybody, graph these 2. You don't have to be perfect with the way you put them. I just estimate where they go. And then write 2 inequalities, just like the example was, to compare them. Take about 30 seconds. It shouldn't take any longer than that. Okay, again, you don't have to get fancy with this, everybody. Draw yourself a quick number line. You know 0 is going to be here. A negative value, if this is -1 and this is -2, you know -1 3/4 will be kind of right here. Again, it don't have to be perfect. You know it's going to be right there somewheres. And then 2.7, if this is +1 and this is +2 and this is +3, you know 2.7 will kind of be right here. Again, you don't have to be perfect. If all you showed me was -1 3/4 and +2.7, that's fine. I just wanted to show it for everybody else. So that's where those two numbers should be. And it says write two inequalities. Well, we know the negative number is smaller than the positive no matter what we do. So the bigger mouth has to be eating that one, the 2.7. Same thing, have the big mouth eat the 2.7. That's what it means by write two inequalities comparing them. Okay, here's ordering numbers. It says write the following numbers. And this was just like our bell work. We had something similar to this, but now we have two different versions of numbers. We got fractions and we got decimals. -4/5, 1.8, 3/2, and -1. It says graph the numbers on a number line. So -1's there. -4/5 is almost -1 if you're going from right to left. So that's where -4/5 is here. +3/2 is the same thing as 1.5. This one's 1.5. That's why it's here. And then 1.8 is almost 2. It's almost 2. So that's where they should be graphed. So from the graph, you can see the order just going left to right, -1, then -4/5, then 3/2, then 1.8. Simple as that. Okay, on the back again, do these. Write these in increasing order. If you need to, put them on a number line. If you put them on a number line, don't rewrite them. There's no need to. Take about 40 seconds or so to do that. All right, again, if you used a number line, it'll look something like this. You didn't have to. The directions didn't have to. Most people don't like doing them. So -3 would be your smallest one. So that'd be like -1, -2, -3 here. So that's this one. It'll be there. -1.5 would be next. If this is -1 and this is -2, then -1.5 would be there. That's this one. Then -1 would be next. That's that one. So then we got 0, which is not considered positive or negative. That'll be this one here at 0. Most people are good with that one. Then we got 1/3 and we got 2.5. We have to determine which one of those is smaller. 2.5 is two whole numbers and then a half of one. So this 1/3 has got to be next. So if this is 1 and this is 2 and this is 3, then 1/3 is going to be about right there. And then 2.5 will be 2.5 will be right there. So that's the order they should be in. -3, then -1.5, then -1, then 0, then 1/3, then 2.5. There's your order. Finding the opposites of a number. How far is -4 away from 0? It is 4 away from 0. So if you're talking about this number, the opposite will be on the other side of 0. Again, that's the difference between absolute value and opposites. Opposites can be negatives. Absolute values cannot be negative. So the opposite of -4 is 4 because they're both 4 units away from 0. The origin is considered 0 when you see that word origin. In this case, with one variable, it'll be 0. When we have x and y, it'll be 0, 0, both of them. Okay, the absolute value of a number. If A is positive number, then the absolute value of A is A. An example being the absolute value of 10 is 10. If A is 0, then the absolute value of A is 0. An example being the absolute value of 0 is 0. 0 is, there's no distance from 0 to 0. So anytime you're talking about the absolute value, if it comes out to be 0, that's how far away it is from 0. If it's negative, then the absolute value of A is negative A. So the example being the absolute value of negative 10 is 10. So notice this negative value becomes positive. If there is a 10 on the inside and then a negative up front, then it acts just like negative 1 times the absolute value of 10. And then when you do the absolute value of 10, you get 10. Then this negative 1 comes down to make it negative. That's the only way it can become negative, because absolute values can never be negative otherwise. That being said, let's solve a couple of them. The absolute value of x is 3. So there's two values, both 3 and negative 3 are that far away from 0. So if you're looking at it, this is saying what number has a distance of 3 away from 0. Most people are okay with the fact that 3 is 3 away from 0. But remember, there's also that negative 3 is still 1, 2, 3 units away, just like this one's 1, 2, 3 units. So it's both 3 and negative 3. When it says the absolute value of x is negative 2, the distance is never negative. There's no number that has a distance of negative 2. There's no such thing as negative 2 units away from something. That's why there's no solution when you have something like this. So what about this one? On the back, evaluate this expression. What number is the absolute value of 1/2? Take about 15 seconds. Again, don't create any new numbers or anything. Not asking you to try to be a psychic or anything. We're going to use, it's going to be some form of the number 1/2. We just have to determine if it's positive or negative. It's asking how far away is 1/2 from 0. The distance is 1/2. Remember, it doesn't become negative because there's no such thing as a negative distance. What about the absolute value of negative 1.6? Take about 15 seconds on that one. We're going to do one more after this one. Again, the question being asked is how far away is negative 1.6 from 0? There's no such thing as a negative distance. So it's always going to be a positive value. The distance is positive. Then what about this one? What about negative absolute value of 3? What does this one simplify to? This one, these right here act like a grouping symbol, everybody. So you do that first, and you please excuse my dear Aunt Sally, the P part, the parentheses. So we ignore this negative right here. So that says the absolute value. How far away is 3 from 0? It's 3. Then this negative comes down in front of it to make it negative 3. That's the only time something will become negative, if it looks like that. Okay, here's number 5, example 5, using a counter example. Remember, anytime you make a counter example, once you prove it's false, you don't have to prove it's false again. So we're deciding whether it's true or false. The first one says the expression, the absolute value of A is sometimes greater than the number. Well, it's true when A is less than 0. So all this is saying when A is less than 0, it's saying when it's a negative number. If something's negative, then when you take the absolute value of it, it's going to be greater than it. So the absolute value of, let's say, -2, the absolute value of that is 2. That's greater than it. So that's an example right there. That makes it true. The second one, B, says the expression negative absolute value of A is always less than A. Let's do this. Let's use the same thought process real quick. That's not going to be true. Let's think of a counterexample. This one says, what about if A is -3? So negative absolute value of A is -3. That's not less than -3. So if we plug in place of that A right there, we have negative absolute value of -3, which becomes -3. Then this comes down, and it becomes a negative times a negative, which is 3. That is not less than -3. 3 is actually greater than it. So be careful when anytime you see this. This is just like one of those test taking things. If you see the word always or never, oftentimes that's going to be false when you're talking about a true or false answer. Okay, on the back, everybody, you don't have to copy these down, but I want you to do the problem. It says decide whether the statement is true or false. If it's false, give a counterexample. The expression, the absolute value of A is always positive. Take about 45 seconds on that. See if you can come up with something that makes it negative. Okay, this one actually kind of gets caught up in the wording a little bit. Remember, anytime you see always or never, a lot of times that's going to be false. This one's going to be false only for this one reason. Let's check 3 different types of answers. The absolute value of a negative value, let's say -1, is going to be 1. That's positive. The absolute value of a positive value, let's say 1. The absolute value of 1 is 1. So both of those are positive. So far so good. With negatives and positives, they're both going to be positive. What about, and this is what I was talking about a minute ago with just the wording of it, the absolute value of 0 is what? 0. 0 is not considered positive or negative. So the only reason A is false is because of 0. So A would be false because 0 is not considered positive or negative. Do the same thing with this one. Take about 30 seconds. See if you can figure out a counter example to the absolute value of a number is always greater than the number. Again, you don't have to get fancy. Just think negative number, 0, positive number, and let's see what we got. The absolute value of -1 is 1. That's greater than it. 1 is greater than -1. The absolute value of 1 is 1. Is this 1 greater than the absolute value of 1? No, it's the same. So there's your counter example right there. False. Because a positive number is not going to be greater than it. Okay, then we have a checkpoint problem. It says compare negative absolute value of -4 and 4 using less than, greater than, or equal to. Negative absolute value of 4, this is going to become 4. Then this negative is going to come down and become negative in front of it. It says to compare that and 4. The big mouth has to eat the bigger number. So it should look like that. The negative absolute value of -4 is less than 4 for that one.